So today I'm going to be explaining present value. So defining present value and the formula. So present value is the idea that your money in the future has less value than it does today. So in other words, this is the value in current time of funds that will be received in the years to come. So the formula we use to calculate present value is future value, so the number of years, divided by 1 plus the interest rate of payments to the power of n, so the number of years. So why is money worth more in the present rather than the future? So due to the time value of money, meaning that the value of the money you own today is worth more than it is in the future. So the common cause of this is inflation, which in short increases prices of goods over time. However, due to these price changes, your dollar's spending power becomes less powerful. So in a good economy, when inflation increases each year, the dollar you make in a current year is going to become less powerful if you look at it in the future. So that's really the ideal of present value. So opportunity cost is another predominant reason for why your money today is worth more. So instead of spending the money you currently have, opportunity cost in this case advocates for individuals to invest their residual cash. This compensates for the amount of money that would be lost if you leave large amounts of cash in a checking account with low to zero interest. So the main variables that impact the present value of future money. So there are three main variables that impact this. So the size of the future payment. So like a smaller payment, so like $2 or $100 versus a larger payment of $1,000 or $10,000. So the present value is going to be different depending on if it's a smaller or larger value. So two, and how long the payment will be received, which is often calculated in years. So if the payment is going to be received in 1 year, the present value will be greater than if it is going to be received in 10 years. So this is due to the inflation that would happen in 10 years. And then nominal interest rate is the third reason. So the I in the equation. So if the interest rate is high, 20%, the present value will be lower than if it is 2%. So this means that the nominal interest rate and present value have an inverse relationship. So here's the example I created with the solution. So the present value of 3 coupon payments of $60 received in 1, 2, and 3 years. So that's your C value, and the face value payment of $1,200, your FV value received in 3 years. So determine the price of this bond if the interest rate is 8%, which is your I value. So step one, you use the equation bond price equals C divided by 1 plus I plus C divided by 1 plus I to the power of 2. So, and then each corresponding year will be to the next power. So 3 years will be to the power of 3. And your face value is always to the greatest power. So in this case, it's to the power of 3. But if you have coupon payments for 8 years, then your face value would be to the power of 8, for example. So each power represents the corresponding years. And then step 2, you just plug in the values from the question and get the solution. So it's a pretty straightforward question. And just make sure to always count the exponents for the denominator and always put your face value to the highest exponent. And then this would equal, in this case, $1,107.22. And then here's the citations as well. So this is my crash course on present value.